Alright, here we are, exam 2, problem 4. You slide a 50 kilogram crate across a concrete floor for 10 meters, and then you slide it another 5 meters across a wax tile floor. Coefficients kinetic friction for the two floors are 0.7 and 0.4 respectively. If you slide the crate constant velocity, determine how much work you did on the box crossing the concrete floor. So part A. Well, the force we have to supply in order to move the box, right, across the concrete floor is just equal to and opposite the frictional force, right? So the work we do on concrete, is force on concrete times the distance on concrete. All right, the force on concrete is 0.7 times the mass, 50 kilograms, times 9.8 meters per second squared, right? So 0.7 times the weight is the force we have to apply, and we go a distance of 10 meters. So what does this all add up to? 0.7 times 50 times 9.8 times 10, 3,430 newtons. 3,430 newtons. Okay, in part B, we're sliding across the tile floor. We'll call that WT, and the force, the tile, and the distance we go on the tile. All right, so the coefficient of friction here is 0.4 times 50 kilograms times 9.8 meters per second squared times, and this time we only go 5 meters. All right, so how much work do we do getting across the tile? 0.4 times 50 times 9.8 times 5 gives us 980 newtons. 980 newtons of work is done by you on the box, moving it across the tile floor. Now, part C, the total work you did on the box, right? Well, this is easy, right? It's just the 34, work on the concrete plus work on the tile is 3,430 newtons plus 980 newtons. All right, let's get that sum. 4,410. 4,410 newtons. Okay, the total work part D. The total work done by friction. Total work done by friction. Well, the force of friction is opposite to the direction of motion, and it goes the same distance, and the force of friction is the same as the force we applied. So it turns out the force of friction does exactly the opposite to the work you do on the box, right? And so friction does minus 410 newtons of work on the box, right? So friction in terms of energy completely negates everything you did. That's why the box has the exact same kinetic energy before and after you finish, right? And then part E, right? What is the total? Well, let me change my notation here. Human total, right? Or work you do on the box. Work you do on the box. Work friction does on the box. Now it'll be a little clearer. The total work is the work you do, right? Plus the work of friction equals 0. Total work done on the box is 0 because friction kept us from increasing the energy of the box. All right, that's it for problem 4.